All right, so again, we're going to be using Pythagorean's theorem, but today we're not just focusing in on solving for the hypotenuse, we're going to be focused in on solving for lengths of legs as well, and knowing how to put it in our formula the right way to solve for either one. So taking a look at number one, we have this triangle here, and obviously it's not the hypotenuse that's missing, it's a side length that's missing. So let's pretend that side length is b. We put it into our formula, 5 squared plus b squared equals 13 squared. Squaring 5, we get 25 plus b squared equals, squaring 13, 169. Subtract 25 from both sides. Doing inverse operations, b squared is now equivalent to 9 minus 5, which is 4, 6 minus 2, which is 4, and bringing down the 1, 144, which makes this really easy because 144 is what we call a perfect square. And the square root of 144 results in 12 because 12 times 12 is 144. So in this case, that side length is 12, and 5, 12, 13 is one of those Pythagorean triples that always results in a right triangle. So again, it's very simple, but now we're just doing some opposite things so that we can solve for B instead of C like we saw yesterday. All right, let's take a look at the next one together. So for this one, again, we're solving for b or a or x for that matter. You don't have to write it as b. So we have 15 squared plus b squared equals 25 squared. I know that 15 squared is 225, but if I wasn't sure, you could take out your calculator and do 15 squared plus b squared equals, and I know that 25 squared is 625. Subtract 225. We get b squared equals 400. And 400 again is a perfect square, making this very easy to solve, and b is equal to 20. Okay, so again, very simple, and if you know how to solve a regular equation, you should not have any problems with this at all. Let's take a look at two more together before you're on your own on the front. And remember that the directions do say to write it in simplest form if needed. So for 3, we have 6b and 18 for c. So we have 6 squared plus b squared equals 18 squared. 6 squared is 36 plus b squared equals 18 squared, which is, I know, 324. Minus 36 from both sides. We get b squared equals 11 minus 3 is 8, 288. Now, 288 is not a perfect square, and I can prove that because if I take out my calculator and clear it, I do 288 square root, and I get about 16.97. So it's not a perfect square. So I'm going to make my factor tree, and 288 is 2 times 144, which 144 is a perfect square. So in simplest radical form or simplest square root form, I take the square root of 144, I get 12, and I leave the square root of 2. So my final answer would be 12 square root 2. All right, number 4 I'm going to do with you, and then you're on your own for 5 through 8 on the front. So number 4, again, this time we're missing a. So we have a squared plus 8 squared equals 16 squared. So that's a squared plus 64 equals 16 times 16, which I know is 256. Subtracting 64. We get a squared equals 192, which again is not a perfect square. So we're going to do this factor tree of 192. And luckily, half of 192 might give us our perfect square. Let's see, 192 divided by 2 is 96. No, it does not. 96 divided by 2 is 48. 48 divided by 2 is 24. 24 divided by 2 is 12. Woo, long factor tree. So 2 times 2 times 2 times 2 times 2 times 2, that 6 2's there is going to be our perfect square. And if you remember, 2 times 2 is 4, times 2 again is 8, times 2 again is 16, times 2 again is 32, times 2 again is 64. So this is going to be 64 times 3 that we have to take the square root of. Square root of 64 is 8. Leave the square root of 3. So A equals 8 square root 3. Okay, so you can pause the video here and try 5, 6, 7, and 8, or come back when I'm done with the parts on the back. So on the back, we have some word problems, and the hardest part with a word problem is making sure that you are actually drawing an appropriate picture and setting it up correctly. So we have a 15-foot ladder and need to reach exactly 9 feet up the wall. How far from the wall should you place the ladder so that you reach your desired location? So we have a 15-foot ladder. So obviously, the part leaning is going to be our 15-foot ladder. And we want to reach exactly 9 feet high. So this side here is going to be our 9 feet. And then how far from the wall is going to be the distance that we have to solve for. So we could call that x or a or b. So we have x squared plus 9 squared equals 15 squared. So x squared plus 81 equals 225. Subtracting 81, x squared equals 5 minus 1, which is 4. 12 minus 8, which is also 4. Bringing down the 1, 144. Making this really easy to solve. So x is 12 feet. So if we place the ladder 12 feet from the bottom of the wall, it will reach exactly 9 feet up the wall. I'm going to skip number 8 and go right to number 9. You're going to come back to 8 on your own. So number 9, we have a barn roof covers a span that is 32 feet across. The peak of the roof is 23 feet above the walls. Find the length of each side of the slanted roof. So this is a little bit tricky because a right triangle wouldn't necessarily represent the scenario. When you think of a roof, you need to think of something that's more like an isosceles triangle. So here's my roof, and the roof spans 32 feet across. And its peak is 23 feet high. And we want to find this length here. So now we also have to keep in mind that since it's the whole barn roof, this would only be 16. And now we have enough to use Pythagorean's theorem. So we have 16 squared plus 23 squared equals x squared. 16 squared is 256 plus 23, I don't know off the top of my head, it's not a common one. 23 squared is 529 equals x squared. Adding those up, I wrote 526, it's 529. 9 and 6 is 15, carry the 1. 5 and 2 is 7, plus 1 more is 8. And 5 and 2 is 7 again. So we have 785 equals x squared. Now, I don't believe 785 is a perfect square, but we'll check it. We get about 28 feet. In the directions, it didn't necessarily say that we had to round it there, so we're going to leave that 28 feet as our answer. So now you're going to go back to all the questions that we skipped. Be very careful when you're setting up your word problems. I'll be around to help you out to make sure you're doing those correctly.